Hi, and thanks for joining our presentation of Quotebank, a corpus of quotations from a decade of news. Now, before I start, let me make a brief shout out to my collaborators, Mikhail and Bob, and especially Tim, who did most of the heavy lifting on this project. In the spirit of full disclosure, this talk is an extended advertisement of a paper that we recently published at Wisdom. But today I want to focus more on the data and less on the methods. Since the topic of this talk are quotations, let's start with the definition. And the most accurate one I could find is this one by Ambrose Bierce. Now, obviously, this is a bit tongue-in-cheek and not quite serious, but it does apply to our current situation in which we have a lot of misinformation and disinformation, and information is taken out of context on the web. So clearly what helps in this situation is looking at a bigger picture with more data. So in this case, more quotations. As an example of this, we could consider the case of Lindsay, who is very well known for completely reversing his opinion on Donald Trump after the 2016 election. So one thing we could do here is do a data-driven approach and see, is there some selection bias in the quotations that got him this perceived opinion, or is there actual truth to the matter? So how would we set up such a study? This fairly simple 5-step data preparation. We would have to find all quotations that we can find that are attributed to Lindsey Graham. So in this case, we found about 40,000. We would have to select the subset of quotations in which he talks about Donald Trump, in our case about 3,000. Then we can apply off-the-shelf language models to those quotations. Here we use BERT embeddings, but anything would work. We would then bin the quotations by month and aggregate. Here we use just arithmetic mean centroids of those binned months. And then we can project the centroid vectors for visualization, for example, with PCA projection. Now, if we look at a visualization of those two principal components, we find that we already have two identifiable clusters here. And if we colorize this by year, then we find that clearly there is some difference between the data before and after the election. But obviously, this doesn't tell us anything about what is actually contained or what this trend is. So one thing we can do is inject artificial data and plot the centroids of artificial positive and negative statements about Donald Trump. And then we see that clearly on the left, we have more negative sentiment, and on the right, we have more positive sentiment. And finally, we can do some cherry picking and look at what's actually in this data. And then we find that clearly the position before the election was a lot more negative than after the election. So this doesn't look quite like nothing happened here. And this is a nice indication that if we look at a large number of quotations by Lindsey Graham, we do indeed see a shift in his stated opinion. Now, this is obviously just one single example for one politician where this is already quite well known, but I think you can see the applications of having this amount of data. And indeed, the amount of data is actually the limiting factor to such investigations, because everything I just showed you can easily be done in an afternoon, except finding the unique quotations. So that's actually the problematic part that obviously cannot be done manually and has to be done at scale with good processing software. And this is where our primary two contributions come in. So in the paper, we presented QuoBERT, a framework for quotation attribution at scale, and then use this to derive Quotebank, a database of quotations from the news. And today I want to focus mostly on the Quotebank aspect, but let me give you a brief overview of how QuoBERT actually works. So in the first step, we can just annotate candidate speakers and quotations in the corpus. That is fairly simple with entity extraction or quotation extraction. And then we can use pattern-based bootstrapping methods to identify simple pattern-based quotations. So those methods work quite well. They have a very high precision, but a low recall. So essentially, we're halfway there now. And in the second step, we can use the parallelism in the data to identify harder to find quotations, because we already know the speaker and the quotation in a context where they are matched by a pattern. We can now match them in a context where they are not included in a pattern, so an implicit context that would be very hard to find otherwise. And then we simply use this on a scale to train CoBERT, a neural model that is based on the BERT architecture, and then apply this architecture back to the full corpus to extract Quotebank. So in numbers, we applied our approach to 160 million English news articles from almost 400,000 unique web domains that spanned 13 years. And what we got out is 178 million unique attributed quotations, so quotations and their speakers, or most likely speakers, by 900,000 distinct speakers. And overall, we find that we have about 1 million quotations per month, and we have a nice distribution of speakers where we have a couple of the typical candidates that are very frequent. So these are Barack Obama or the Pope and so on. But we also have a wide range of other speakers that are less frequent and add to the overall image. Now, the interesting part for you is probably the data itself. And yes, we make this available in two different forms. So one is the very raw article-centric data, where we have the article title, the source, the publication date, and obviously we cannot publish the content of the articles, but we have the sources, so you can get them yourself. And then in these articles, we annotate each of the individual quotations, including the text, the offset in which it occurs in the article, a context window to each side if you want to use some neural model to try to attribute them yourself, as well as all speaker candidates that we match to Wikidata IDs and probability scores for those candidates. So you can always extract the most likely one. Now, this is a very large data set, and it's very unwieldy if you just want to focus on the quotations themselves. So we also publish a quotation-centric data set in which we already aggregated all the individual occurrences of the quotations into one canonical occurrence, which then has a first mention date and a most likely speaker that is already pooled over all the individual occurrences. So if you just want to work with attributed quotations, then this is your data set and you would be using those attributes most likely. But if you want to look at possibilities for disambiguation or looking into the errors in this method, we also have the speaker candidates with the most likely, or ranked by a probability score for the most likely speaker, as well as the URLs of source articles to link this back to the original data set. However, this is still a quite large data set that has a couple of dozens of gigabytes. So it's not extremely easy to use if you just want to look quickly for a couple of quotations by certain speakers. So we also are working on a web interface that you can use to search this data, which is the direct access to Quotebank. So you can search both data sets, the quotation-centric and the article-centric data set, and you have multiple ways of faceting your search. So you can search for text in the quotation, for certain speaker attributes, for URL domains, so the publishers of the news, or you can limit it to a certain time range in the data. And the output is then neatly presented with the histogram of the frequency of the quotations, all individual quotations by speaker and the sources. And you can also export this data if you would like to, or share it with someone via a hard link. And this directly brings us to hopefully the most interesting part, which is what is available for you to use. So we make the full Quotebank data available, which Zenodo was kind enough to host despite the size. We also have the web UI that you can play around with, but please be kind, it's a beta version and we're very grateful for feedback. And we also publish CoBERT. So if you have your own data set where you want to attribute quotations, then you can use this directly out of the box. It should be language agnostic and fairly simple to use. And with that, I would like to say thank you.